Okay, we are going over exponential functions, and we're going to do one more example for an exponential, how exponents work. And let's start with, let's take 5. Oh, I'm still in eraser mode. So we got 5. Let's take 5 to the first power. Bree, what's 5 to the first power? Nice. 5 to the first power is 5. Cody, what's 5 to the second power? 25. Perfect. How about 5 to the third power, Canyon? Nope. It would be 5 times 5 is 25. 25 times 5 is 125. And I'm going to show you the way that I do these. So then I know how far I've gone and what I have left. So 5 to the fourth power is 5 times 5 times 5 times 5. So what I like to do is I'll draw a little triangle. 5 times 5 is 25. And then 25 times 5 is 125. And 125 times 5 is 625. Is that right? 625. So that's my answer. Oh, she must have mistaken the exponents for a cat video. So that's how I do exponents. That's how I make exponents easy to follow, is I put those little triangles under there. Now, I'm going to quiz you on what we just learned. What is 5 to the 0 power? 5 to the 0th power. Cody. Nice. 5 to the 0 power is 1. Now we'll do 5 to the negative 1 power is 1/5. And 5 to the negative 2 power is 1/25. So that's the pattern for exponents. If you recognize and understand that pattern, you're going to be well on your way to understanding exponents. Okay, next piece. Exponential growth. I want you guys to see. How can I find that? If we look at charts for the coronavirus, we will see exponential growth. And we might see exponential decay if we're looking at it over the whole course of the coronavirus. We'll see growth and decay. It's like my Wi-Fi is getting sketchy. So here are the numbers for Chelan County. If it's going to load. While it's loading, let's look at an exponential function. So let's just look at y equals 3 to the, where's my little calculator? Let me get my calculator. Yeah, I think looking for those live updates, it kind of messed it up. Okay. So y equals, so can you see, is it pixelated now? Can you see my Desmos calculator? Oh, you cannot see my calculator. If you open up your Desmos calculator and in the lower left-hand corner, there's this little keyboard. If you open up the keyboard, it will have a little A squared button. If you hit that A squared button, oops, that gives me squared. I don't want squared. If you do A to the B power, you can put whatever you want up there. And so if I have y equals 3 to the x power, can you see my graph or is it still pixelated? Can you see the red line? Okay. All you need to do is see the form of the red line, how the red line goes, how it comes up really slowly, starts to rise faster, 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 and then it's almost vertical. That's exponential growth. Let me go back to the paint and see if I can show you exponential growth. So exponential growth, is this screen pixelated too? My paint? Oh my gosh. Exponential growth looks like this. Let's see if this comes out. Exponential growth is flat, gets steeper, 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 and almost vertical. That's an example of exponential growth. What I'm going to do is I'm going to stop sharing my screen and I'm going to see if we can, if I share it again, if it'll become less pixelated. Okay, can you see the screen now? Is it still pixelated? You can see it now? Okay. All right. So does anybody need these notes still? We're going to graph a couple problems. All right. So what I want to do is I want us to graph I want us to graph these problems. First one, we'll do in black. Nope, our graph is going to be black. So let's do it in red. Y equals, let's just do the one we just did, 3x. So if we're going to graph it, I want you to put it in a table. I want you to put it in a table. Now I cheated on that vertical line that was drawn with my finger, not with the pencil. So if I say, let's say x is -2. If x is -2, then I have 3 to the -2. Well, we just did it. 3 to the -2 is 1 over 3 squared. So it's 1/9. So -2 is 1/9. Does that make sense how I got that? Same thing as the patterns we just did. If you have a negative exponent, it turns it into the denominator of a fraction. Okay. -1. 3 to the -1 equals 1/3. 0. What does 3 to the 0 power equal? Show me with your hands. What does 3 to the 0 equal? Nice. Nice. 3 to the 0 is 1. And then I'm going to do, I want to do 1, 2, and 3. So I'm going to do 1, 2, and 3. So 3 to the first power equals 3. 3 to the second power equals 9. And 3 to the third power equals 3 times 3 times 3. That would be 9. That would be 27. So there it is. If I'm going to graph, oh, wait, what? All right, so if I'm going to graph this red one, I'm going to graph the points that I could actually see. -2, 1/9. So -2, 1/9 is way down there. -2, 1/9, way down here. -1, 1/3 is right there. 0, 1, 1, 3, 2, 9, and then 327 is way up there where I can't see it. So I have a line that looks like that. That's exponential growth right there. That's exponential growth. I'm kind of off on the... That's better. Kind of. A little bit. So that's your exponential growth. So, and if we look, I don't know if this is going to be pixelated, but here is the Desmos. There it is. There is our y equals 3x right there. -2, 1/9, 1, 1/3, 2, 2, 9 right there. And then 3, 1, 2, 3 is going to be at 27. Poke. Right there. All right. So there's your exponential growth for that and how to graph it. Now what we're going to do is we're going to watch a Khan Academy video, Intro to Exponents. So I'm going to pause this video.